Hello, let's do our today's DSA journey. We are using this Chai visualizer dsa.chaicode.com. Use this link to get a 7-day free trial on this platform. Let's start. So today we will be covering this question, that is valid triangle numbers. Count triplets that form a triangle. Given an array of non-negative integers representing side length, count how many triplets can form a valid triangle. You can see the tags here. So we are given this array where we get the all of the side length. We need to combine it so that we can create triangles. Okay, so first let's draw a triangle. Okay, where is triangle? Okay, let's draw a triangle. So suppose this is a triangle. It has a side length of, let's suppose this is B and this is C. We have a triangle with this three side length A, B and C. The triangle is valid if and only if it follows this condition: A plus B is greater than C, greater than A, and A plus C is greater than B. So this is actually the condition to satisfy a triangle. Every two sides should be greater than the third side. This is the condition we have to fulfill. Okay, so we are, let's given this array 2 3 3 4 5. 3 4 4 4 5. This is the array which we get. We have to calculate how many triangles we can get from this. How could we do this? Okay, the one and the brute force approach is using three for loops. This is I, let's suppose another loop is J and another loop is K. We have three loops. I should be starting, J should be I plus 1 and K should be J plus 1. But before doing this, we have to short this array. Okay, why short? Let me explain in a bit. We have using three loop three loops to to get the value of the triangle length and should be satisfied these formulas. Okay, but we have to short the array. Let's visualize it. Let's take after this is already sorted, so we have to sort because not every time the array would be sorted. So after that start. Okay, so let's see here. The I at 0, the j at I plus 1, the k at j plus 1. So if you just perform these three operation here, a plus b equal to c, you can clearly see these three conditions satisfied. But we don't check here three condition. We only check here only one condition, and the condition is, suppose the array name is ARR. So this we have to check only this condition. We just have to check only this condition. Let me explain why. Only this condition should be checked because the array is sorted. The array is sorted. Okay. The reason is the array is sorted because we sort it. We start I from 0, j from I plus 1 and k from j plus 1. So in any given condition I should be smaller than j should be smaller than k in any condition because we started everything from here, everything started from here. So from the starting also this condition satisfied, and we sort the array. We sort the array. So array of I is always less than array of j is always less than array of k. So for every condition we get this two. K should be greater than I and j should be greater than I is the most smaller, and the element at ith index is also smaller because we sorted the array. So k is the largest one. Okay, so there are three conditions we are getting. These three. Let's just copy it. Okay. So just if we do this, the A should be array of I, B wait just a minute. The A should be array of I, the B should be array of J, and the K array of K should be C should be array of K. Change the condition here, and now K is the largest one. This K is the largest one, and just see these two conditions. We only checking this condition here. We check in if statement this condition because here you can clearly see we added array of k here, which is the largest among these three elements. When we add the largest among these three elements, this is always be greater than, because this is the largest than array of I. Array of k is always is either equal or larger than array of I. Okay, similarly it should be either equal or larger than array of j. So when we add these two elements to array of k, this condition always satisfied because we sorted the array at the first. So for that reason we just always check only this condition, that if only this condition satisfied or not. Okay, only this condition. If this condition is satisfied or not, we just check it every time. This condition where array of k is great, array of k, the value of array of k is larger than value of both of these. So we just check only this condition, and remaining two condition is always satisfied because this element is the largest one among them. Okay, for that reason we sorted the array. So you can clearly see in the visualization, we just check this one, just this one if condition. If it is possible, we just make the count plus plus or increase the count. Now we increase the k. Do the math. 2 plus 3 5. 5 is greater than 4, so increase the count. Then we again got 2 plus 3 5. 5 is equal to 5, so not greater than the count. Then increase the j. Simple looping. Increase the k again. We getting the elements. Increase the I. Increase the k. Increase the j. Increase the I. We get the element. Okay, this is the brute force approach. Let's write the pseudocode here. We are taking a function that takes an array, first sort array, then use 3 loop. One is starting from 0 to n minus 3. Another one is starting from j, it is I plus 1 to n minus 2. And the third loop k is starting from j plus 1 to n minus 1. Then inside this loop, just check this condition satisfies or not. Simple. If it is satisfied, then count plus plus, and we also have to initialize count as 0 here. We have to initialize it, and at the end return the count. See, return the count at the end. Let's see. Yes, we have the solution. Copy it, go to the question on LeetCode, paste it here. Okay, we paste it here. Now just simply write the code in C++ in n equal to nums dot size. Then let's first sort the array. Sort size, not size, nums dot begin dot end or int I equal to 0, I less than n, not n, it should be n minus 2. Should let's do n minus 2 here. Now the second loop, that is j loop, that started with I plus 1 and goes till n minus 1. Then another loop, that is k loop, that's starting from j plus 1. Inside these three loops, check the special condition, the only one condition, nums of I plus nums of j is always greater than nums of k. If it is possible, just increase. Okay, we don't specify the count here. Count equal to 0. Then we just do count plus plus here, and at the end return the count here. Count here. Let's run it. Let's see what happened. Okay, we got an error. Redefinition of k. Previous definition here k equal to j plus 1, k less than n, k plus 1. Okay, let's give it a shot. It should work. Okay. There is a semicolon missing. Just run it. I think we should give TLE because it's a O of n cube. So, oh, it's work. It's work. It's work. The O of an n cube solution is accepted. Yeah, the constraints are pretty small. That's why. But we have another, that is optimize approach. Okay, which says just sort the array, fix one element, and use two pointer in other two to find other two elements. Let's see. First sort the array. It is already sorted. Then put k at the last index. At the last index of the array, which is the highest element or the highest length of the triangle. Then put two pointer, one at the starting, another one at the k minus 1 point. Okay, so we now got a point in a sorted array. We just put three pointers here. Now just do the similar checking because if we check, like 2 plus 4 is greater than 5 because 2 plus 4 is 6 is greater than 5. So we add right minus left to count. Okay, let's see this one. Okay, let me copy this thing. We are putting k here, j at the just previous index of k, and I at the starting index. We sorted the array at the first. Okay, now just calculate. It's 2 plus 4 is greater than 5. Yes, it is greater than 5. So it satisfies the triangle equation. Then how many number of triangles are here? Actually the number of triangles is j minus I. Why? Because the I is at the smallest index. So the value of array of I, so this should be here. Array of I is the smallest value. Array of I is the more bigger value, and array of k is the greatest value. So if we increase the I till j or j minus 1, till j minus 1, everything satisfies the condition. Let's check it. If we put it to 3, 3 plus 4, 7 greater than 5. Put it here, 4 plus 4, 8 greater than 5. These all are valid triangles. Why? Because the array is sorted. This array is sorted in increasing order. So if the I satisfies here, then I plus 1 is also satisfied. It's satisfied till j minus 1. So the number of valid triangles are become j minus I. It becomes j minus I. We just put it here, right minus left. We just add it to the count. Because if we increase the left till 4, we get everything is valid because now the pointer at the left is valid, so everything that is increased value should be valid. Then we just move the right minus minus and we just check it is also valid because 2 plus 4 is 5. So there is another triangle. These two 4 are different. These two 4 are not equal because these two have different values. So this 3 is also valid, so we do right minus left here. That is 2 minus 0, 2 valid triangles. 2 4 5, 3 4 5. These two are valid triangle. For this case, 2 4 5, 3 4 5, and 4 4 5. These three are the triangles. For this case, two triangles. Now again do it. Then it is 2 plus 3 5 equal to 5. For this case, it is not a valid triangle. We increase the left plus plus. Because it left and right are in equal places, we just reduce the k one step. The I and j according to this. Is it valid? Yes, it is a valid. And we got here two triangles because 2 4 4 is a valid triangle, 3 4 4 is a valid triangle. Okay, then we reduce the right. 2 3 4 is again a valid triangle. Okay, now reduce the k again, put the left and right, check. Okay, it is a valid triangle, and the count is right minus left always, or j minus I if you use I and j. We got 9 triangles. Okay, let's write the pseudocode here. We got a function which takes an array. First sort the array, then put a pointer, then take or initialize the count with 0 for k equal to n minus 1 down to 2. Why 2? Because we need 3 length minimum to form a triangle, because a triangle has 3 sides. So till 2 we just put down k here, because if k goes beyond 2 like 1 or 0 index, we don't get it. We don't get a triangle. Put the left pointer initialize with 0 and the right pointer at the just end of k. Put the left less than right condition, standard 2 pointer condition, and check the condition, the valid triangle condition. Left plus area of right is greater than area of k. If it is possible, then count plus plus. Also right minus minus if we get triangle for smaller values. Else left plus plus. Simple condition. Just return the count 0. Just return the count at the end. Let's evaluate it. Okay, the condition for increasing count is correct. Sorry, we just increase the count, but this should not be I. This should be right minus left to get the total element in between them. That's my mistake. We nailed it. Just copy it, paste it. It is easier to write code when we have a pseudocode in our hand. Just see this code and write the actual code. First sort the array. We are sorting just to get everything sorted and on the line so that we can perform this operation. Also only one condition check, we just perform that. Let's take the int n equal to nums dot size for int k equal to n minus 1, k greater than equal to 2, k minus minus till the second index. Make the k from the end of the array, put left to be 0 and right to be k minus 1, then just put the left is less than right point if of left plus nums of right is greater than nums of k, then we get a valid triangle and plus the count with 0 and count plus equal to right minus left. So this is count plus equal to right minus left so that we can get all the triangles in between them. Right minus minus just to ensure that for the smaller value we also get triangles. And if it is not possible, we have to go to the bigger indexes or the bigger values. So we increase our left. At the end, just return the count. Okay, it's working fine. Let's submit it. Yes, yes, it's working properly. We just use a for loop from in minus 1 to 2, and inside that we are pointing left at 0 and right at k minus 1. So the complexity will become big O of n square and we don't use any extra space. So the space complexity will be big O of 1. You can clearly see this. Using 2 pointers and fixing 1 pointers, we can easily solve this valid triangle number question. Just go solve it. Use this visualizer. It's really amazing by ChaiCode, dsa.chaicode.com. Use this link. Use this link to sign up to get a 7-day free trial. Go use it, read it, read problem, solve problem daily. They have one feature which is like prep like interview is next week, where you just put how long you have, like 7 days, how many problems do you have, just click start preparing. If you go to complete track, it is the total question. Just put questions, start preparing, go prepare. Thank you very much.